Just started by checking two of the conditions. N times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Amelia is going to do the rest for us. Is that you, Sam?
What?
Never mind. Turn it down a little, Eric. Oh, man.
I always need everybody. Sorry, that was too easy.
She's coming in 7.
Oh, wonderful people.
Like lineup. Well, that's how they like cut.
I know. It's the only way I know it in my hair.
Probably to the
We did do this yesterday, not yesterday. Man, I'm tired.
Oh my.
No, Molly, that would help.
I feel like she was going to be good. We'll be back in under 20 minutes. It's
I knew there's spurs.
right there.
It is right there, you're right.
I knew there's some spurs.
In this case, it's actually just. Yeah, you were right. Yeah, what's your order? If you have to say half a minute. It's kind of funny.
It's a good thing my eyes were open when he walked in. I was cleaning against this, but my eyes at least were open. Alright, so Calvin checked the first two, n times p greater than or equal to 10, n times 1 minus p is greater than or equal to 10. You also have to check that your sample size is less than or equal to 1/10 of the population. So our sample size is 267. So that would have to be, if we multiplied by both sides by 10, that means that our population has to be at least 2670, which there's got to be more than 2,670 college women. I mean, U of O has more ladies in college than that right there. So then after she checked that condition, which remember that condition is so that we can use this formula. If that condition's not met, we can't use our standard deviation formula. These first two conditions are so that we can use a normal curve. And then normal CDF. So once she checked that condition, she found the mean. So the mean of p hat is just p, which is 0.7. And the standard deviation of p hat comes from the square root of p times 1 minus p divided by n, which is 0.028. Then she drew her normal curve, labeled the side that had the values she was looking at. So we want to look at what's the probability that 75% or more have been on a diet in the last 12 months. So normal CDF, 0.75 for the lower bound, really big number for the upper bound, 0.7 for the mean, 0.028 for the standard deviation, and you get 0.037. Questions? No? Alrighty. Did I sign off everybody's homework that did it? No? Yes, no, maybe so. Alright, so today we're gonna be looking at means. So we're going to say in a certain high school north of Grand Rapids, the distribution of ACT scores for seniors is approximately normal with an average ACT score of 16 with a standard deviation of 5. Is 16 really that special? Doesn't it go to 36?
Yeah.
So 16 is kind of blah, huh?
That's
right?
below average.
Below average? What's average?
Average is 19 or 20.
Oh, okay. Well, then I don't know why we want to send Dr. Smith. Well, first of all, who cares if Dr. Smith goes because he's no longer here. Sorry, the whole 16 threw me off because I was like, I know why I chose 16 because the statistical applet, which by the way loaded today, it uses a mean of 16. But then when I was reading it, I was like, oh, that's actually really low for, well, not low, but lower than I would expect. You okay, Maddie? Yep. Okay. All right. So let's say we sent Dr. Smith there to go learn about their ACT prep curriculum. And because, well, I'm a stats teacher, I said, bring me back some data. So I told him to pick a random sample of 15 students. He's going to record their ACT scores and find the mean of the sample. So before we get into this, what is the population we're looking at? Seniors at the Grand Rapids High School. Thank you, Molly. And what are our parameters? So 16 for the mean. And what's the other piece of information? Standard deviation is 5. And what's the sample we're going to do? Or have Mr. Smith do? 5 random students, right? So, like I told you, the reason why I chose 16 is because I have a statistical applet, which I'm going to pull up in a minute, and it's set with a mean of 16 and a standard deviation of 5. So we're going to simulate taking a sample of 5 students, and we're going to find the mean. So, I have to remember, I want this one. Seriously? No, that one. Sorry. Is it just me? Or do I need to zoom in?
No, just see it for
Shelly, are you good? Or you want me to zoom in? Hayden, you good?
I'll say zoom in a little bit.
What do we do?
All right,
Why can't you?
now
Why
here's
is it like moving?
my ignorance. How do I zoom in a web page?
Control plus.
Zoom 9.
What if,
Control. Left control.
Yeah, move your finger
Plus.
plus.
what if I use the control on the right side?
Then you
That's
get
like weird.
instantly explode.
Okay, I'll use the left one. You got me, Nate. I don't want to eat it. And the plus sign?
Yes. Control plus should be the same as equals.
Ah, too far.
It's
Minus?
so, like, fuzzy, it hurts my head.
It hurts my head too.
I think we should not have
And just go get coffee? Yeah! No! All right. So over here, you can see that here's our population distribution, which in the paragraph I said it follows an approximately normal distribution. This is approximately normal. It has a mean of 16. Maybe if I can highlight. Nope, there. See, mean of 16 and a standard deviation of 5. So we are going to take a sample of 5 students. So I'm going to click on the 5. It's going to, well, no, I don't remember if it drops them down individually or not, but down here it's going to give us our mean for the 5 students. It doesn't drop them down. I could have sworn it did. Anyways, so down here we have our 5 random students, and they had a mean ACT score of 15.16. So on your paper, it has a spot for what is the sample mean. So Dr. Smith came back with a sample mean of 15.16. Now we're going to take a few more. Is that your phone again, Eric?
No.
It is.
Out there. I don't think we're outside. Like those little bugs.
I'm not going crazy.
No, I hear it too.
Wait, it's like a little red bug there. That's what it sounds like. Is that red in there? Oh, it's definitely outside.
What is that?
The cicadas.
No clue what it is. All right. Hey, Kim, it's Amber. There's some... Okay, thank you. She's like, I got it. You're awesome, Kim. She's the most helpful lady up front. No! Stop it! We're going to take 1, 2, 3, 4, 5 more samples of 5. And so, if I do 5 more, this time we got a mean of 18.8, so 18.18, excuse me. So put that on your paper. We're going to do it again, sample of 5. This time we got 14.69. And then we're going to do it again. This time 17.41. $16.17. Oh man, I ran out of colors. And last one, 16.73. So, it doesn't specify how many kids go to this high school, but we're going to assume it's pretty large. So if I wanted to get a true sampling distribution, so every possible sample is size 5 from the population, what shape do you think our sampling distribution would have?
Normal.
Who said normal? Okay, let's see if Calvin's right. So this time, instead of taking, well, here, we'll do 5, and then 5, and 5, and 5. And if I keep just doing a ton of samples of size 5, what shape are we getting? Approximately normal. Oh. Try and make that center peak higher than all the rest. There we go. All right. Oh, and hey, look at that. I didn't even do it on purpose. But look at that. Our mean of our sampling distribution is 16. I was looking for the center to have the highest peak and not even paying attention. Look at that. So, right here, I just simulated taking many, many, many samples of 5 students. And we're going to, well, I'll draw the distribution from my computer screen because I can still see it and you guys copy mine. Okay. Something like that. Okay, it's not perfectly normal, but it gets closer and closer to normal. And as you guys saw, the mean of our sampling distribution was at 16. So our sampling distribution became more normal. Oh, one thing we didn't pay attention to, centered at 16. The standard deviation of our sampling distribution was 2.17. You guys believe me or you want me to show it to you? Aw, thanks. You believe me? So standard deviation got smaller. It became 2.17. Sorry. There we go. So I'll wait a second, let you finish writing. So in the box below, it says, what if the population distribution was not normally distributed? Would the sampling distribution still be approximately normal? Anybody want to make a prediction? No? No prediction? All right, we're going to clear this. And I'm going to change our population to, let's go with skewed. So if I take a bunch of samples of size 5, what do you think's going to happen? Are we going to get a normal distribution or a non-normal? Nobody wants to venture a guess. What?
Not normal.
Not normal? Anybody say normal? Maddie says normal.
No, help everyone.
It's not changing much more anymore. Oh, oh, oh. What is it starting to look like? A castle, which has a skewed shape or a more normal shape? More normal. Let's go up to 1,000. I'm almost there. What? All right. So I went to 1,000. So we took 1,000 samples of size 5, and it's not perfectly normal, but it's definitely much more normal than the population distribution. So even when your population distribution is not normal, your sampling distribution will be normal. It would even happen if we started with uniform. Just so you don't have to watch me click, I'm just going to do 10,000 there. And look, it's like really normal. Yes, sir. Why? I feel like I used to know this and my mind is just blanking on me.
I don't know it.
I know why. I'll come back to you. But right now my mind is blanking. All right, so yes, the sampling distribution is normal, even if your population distribution is not. And I guess I should put approximately. Safety words, it's not perfectly normal. What would happen to the sampling distribution if we increase our sample size? What? Decrease variability. Thank you. All right, you guys are going to look at the 3 sentences. Variability. So, 3 sentences, you'll notice more, less. You get to pick which word. Circle the one. That's correct. More or less, circle. Increase, decrease. Circle the correct words for me, please. All right. Number 1, averages are more or less variable than individual values. Less. True. Averages are more or less normal than the individual values. More. Increasing sample size increases or decreases the variability of the sampling distribution. All right, so when we were working in 7.2, we looked at sample proportions. We were in search of a proportion in the population with a certain characteristic. The actual proportion of the population is called the parameter, and we use P. I wrote way too big, sorry. The estimate of the proportion based on a sample is called a statistic, and we used P hat. And my example, which I'll be honest, I failed you all this year, was the orange Reese's Pieces, because I forgot my Reese's Pieces and then I forgot them today because I've had the worst week. I just really have.
So have I.
I'm sorry, Sam.
That's what I'm saying.
I should have written this in orange too. That would have made a heck of a lot more sense than green. But like I said, this week needs to be over. I will bring, no, well, I shouldn't say I will bring them. I'll try to remember to bring them. They're sitting at home.
Their car.
It's just, I can't. I don't know what's wrong with my brain. So today we switched to section 7.3 in the textbook, and we're looking at sample means, which is why we looked at the average ACT score. And we are in search of the average value, or the mean, and standard deviation of some characteristic within the entire population. When we have the mean from the entire population, it's a parameter, and we use mu. And when we find the estimate of the mean based on a sample, it's a statistic, and we use X bar. So today we looked at average ACT scores. On Monday, we're going to do a little activity with pennies, which, by the way, those I have here already, so I won't forget them. But we need about 50 pennies each, and I think I have enough. But if you have some pennies sitting at home, maybe try to remember to bring them. Be better at remembering than I am. So on Monday, we're going to look at the average age of pennies. So those are the two examples that I will focus on when we talk about sample means. So just like with sample proportions, we had new formulas, find mean and standard deviation. We do down here also for sample means. So suppose that X bar is the mean of an SRS of size n drawn from a large population with mean mu and standard deviation sigma. If the population distribution is approximately normal, then the sampling distribution is also approximately normal with the mean of the sampling distribution of X bar is mu. So just like the mean of the sampling distribution of p hat was just p, the parameter, same idea for means. The mean of our sampling distribution is the parameter mean. The standard deviation of a sampling distribution, we take sigma and we divide by the square root of n. So if we look at our formula for standard deviation, it tells us that the standard deviation is going to decrease as the size of the sample increases because we're dividing by n. So if I wanted to cut the standard deviation in half, what do I got to do to my sample size? If I want to take my standard deviation and cut it in half, what do I need to do to my sample size?
Divide it. Triple it.
Quadruple it.
Oh, okay.
And I'll show you why. Quadruple the sample size. And then I'll answer your question, maybe Nate. My brain will allow me to. So if we're dividing by the square root of n, if I want to take sigma and cut it in half, the square root of 4 times the sample size, we know the square root of 4 is what? 2. And, well, I don't know so much about last year. I know in my Algebra 2 class we didn't get to the rules of radicals, but you can break up a radical using multiplication. So the square root of 4n, we can rewrite it as the square root of 4 times the square root of n. And we know the square root of 4 is 2. So if we quadruple our sample size, we're going to take sigma and cut it in half. What was your question, Nate?
Are these formulas going to be on the exam for us, or do we have to memorize these?
These ones, I'm pretty sure you have to memorize. I will double check, but I don't think they're on the sheet. And to be able to use this standard deviation formula, we have to make sure a 10% condition is met, which, remember, is that your sample size has to be less than or equal to 1/10 of the population. So now we're going to do some practice problems. Bless you. You're welcome. All right, so the height of all North Medford High School seniors approximately follows a normal distribution with n, that tells us it's normal, mean of 68.8.
What, inches?
Yeah, it says that, where height is in inches, and a standard deviation of 3.5. Do you know what 68.8 inches is?
5'7".
5'8".
5'7".
5'8". And now you.
5'7". 5.73. Therefore, you can't run.
Miss Whittle.
60 inches is 5 foot.
Yeah. You've been out 5'8.8.
You've been out good.
How did you get 5.7? What did you do in the calculator?
68.8
Divided by 12.
What you thinking about?
Okay, that's 5 foot, and then you have to take that and multiply it by 12, and you get 8.8 inches. It's 5'8".
Why would I multiply that?
To put it back into inches. This is out of 100. I promise it's 5'8", because 60 inches is 5 foot, because there's 12 inches in a foot. All right. This week is not the week. All of a sudden I was questioning my whole thought process of how to do feet. You really messed with me, Sam. All right, so we're going to pick a senior at random. What's the probability their height is greater than 70 inches? So we have our normal distribution. Try to make it fit in here. 68.8 inches. Standard deviation of 3.5. I'm going to use pencil because I can seem to write smaller in pencil. That'd be 71.8, so 72.3. And that'd be 75.8. 78.8, 79.3. Right? 7. Yeah. Okay. 365.3. 62.3. 61.8. 58.8, 58.3. Somebody probably better double check me on that after I really thought 68 inches was 5'7". So we're going to pick a senior at random. What's the probability their height is greater than 70 inches? So we'll say 70 is almost like halfway in between those two. So there's 70. Greater than 70 would be to the right. So how do I find the probability? Normal CDF. What's the lower bound? 70. What's the upper bound? Big number. What's our mean? And standard deviation. So what's the probability a senior picked at random is taller than 70 inches? I'm sorry, say it again.
0.3659.
Thank you, sir. So somebody want to throw that into words for me?
There's a 36.59% chance that a randomly selected NMHS senior is above 70 inches in height.
There is sorry, bad spacing. 9% chance in NMHS senior picked at random. Random, I can spell, is 70 inches or greater in height. Thank you, sir. Any questions about that one? Pretty straightforward, right? Then number 2 is where it changes slightly. So it says we're going to pick 10 NMHS seniors and find the average of their heights. What's the probability that the average of their heights is greater than 70 inches? So this time we're picking 10 seniors and finding the average. So this is where our new formulas come into play. So the mean of X bar is just the original mean parameter, which up here was 68.8. So that's not going to change. Our standard deviation for the sampling distribution, we use that new formula of sigma divided by the square root of n. So sigma is 3.5. I don't know where the 1 came from. And we're going to divide by the square root of our sample size, which is 10, because we're picking 10 seniors. So we get 1.107. Now, what must I also check to make sure I can actually use that formula? So I need to double check that our sample size is less than or equal to 1/10 of the population. Now, I have some seniors in here. Any of you recently looked at your transcripts and looked at your rank?
Oh,
What?
Your rank?
Yeah.
I'll tell you right now.
It'll tell you how many seniors are in the class. Do you remember? Or,
57?
I think I'm 66. I definitely threw in like no.
Sam's got his out. How many seniors are there, Sam?
366.
Thank you, sir.
That's it?
Apparently, 366. So, our sample size
Guess what
was...
rank I am? Take it.
50.
365.
Oh.
One or five.
Are you going to share?
You gotta guess.
I said 50.
165.
Good job, Sam. All right. Sample size is 10. And then Sam just told us there's 366 seniors. What's 1/10 of 366?
36.
36.6. So we're less than the 1/10. So we can use that formula, right? So we're doing good. Now we're going to draw our normal curve and find the probability that the average of these 10 seniors is greater than 70. So it's normal, mean of 68.8, but this time we're using a standard deviation of 1.107. Need one more there. Oh, I should have rounded that standard deviation more. Okay, are you guys okay if we go with 1.1 just to make my, okay. No, it's okay. Eric said no.
It's fine.
No, it's okay. So we have 69.907 plus 1.107. 71.014. Okay, and I'm going to stop because now I know where 70 is. So 70 is a little closer to that one than this one. And we're doing greater than. So we're looking at that. So still normal CDF. Still 70 for the lower bound. And a big number for the upper bound. Still 68.8 for the mean. But then our standard deviation is 1.107. And what do we get when we type that in? 0.139. Is that what you said? Thank you. Somebody besides Nate want to put it into words? Because I know Nate knows how to put it in words. Nobody? It's not the same thing.
We're all going to use the same sentence.
Okay, so what words are we changing, Jillian? Eric, shh!
You're going to say there's a 13.92% chance that 10 randomly selected NMHS seniors have an average height, or have height that is
No, average height is correct.
height that is greater than 70.
Do you need me to write that down? I can if you want me to. I don't got any space. There's a 13.92 chance that 10 NMHS seniors chosen at random have an average height of 70 inches or greater. Any questions before we look at number 3? Alright, so number 3 says pick 50 NMHS seniors and find the average of their heights. What's the probability that the average of their heights is greater than 70? You think you guys can do this one on your own? Sorry, direction.
Yeah.
Yeah, your parent. Yes, you may go share. Now that I know. All right, Maddie. Maddie's gonna do this one on the board for us.
Uh-oh. Bro, juniors are first, but this thing.
Okay.
I just wrote non positive.
Bro, I was
At least I've never put it on my test. I've never seen, they don't release all, but I'm trying to think, I've never seen one. Maybe in like a multiple choice, they might ask like, is the condition met? All symptoms, which condition is not met, and then maybe a list of the conditions. But I've never seen it for your response. No, you can't do it, sorry. That would be nice, save you a whole lot of time, right? Alright, so you can't do this problem because our 10% condition is not met. We want to do a sample of 50 and the same, we're working with the same population, and 50 is bigger than 36.6. So that 10% population condition's not met, so can't do it. Any questions? Alrighty. If you want to try the exit task, that'd be cool. Since I don't know how I ended with like 15 extra minutes. It's unusual for me with this group.